So the next postulate that I want you guys to think about is the side angle side postulate. And remember that that is side angle side. And I want to point out to you that the angle has to be tracked between the two congruent sides. So it's not like we go and we look and we say, oh, it has two sides that are congruent and it has an angle that's congruent. Boom, both triangles are congruent. No. The sides have to be corresponding and the angle has to be tracked between the corresponding sides. So let me give you an example of that. If we, I'm going to go back and copy and paste my first diagram, if I can. I'll have to delete some stuff. Copy.
I think you gotta make it one first. Oh,
And that's good enough. And I just got to delete some. Oops, I got to delete some stuff. Woo! All right, so same type of triangle, right? But now, what I mean by that is, let me give you an example. We know that this angle is congruent to this angle. So when I say side angle side, let's write it as it's written in the book, and then we'll talk about some different scenarios. If line segment AB is congruent to DE and AC is congruent to DF, then, oh wait, we got one more. Now what angle is trapped between those? Okay? What angle is trapped between those? What I'm saying is, yeah, A and D. So I'm saying that if this corresponds to this, and this corresponds to this, right? Mm-hmm. If I could prove the angle trapped between those corresponding sides is congruent, well then I can prove that this whole thing is congruent. So then if angle A is also congruent to angle D, then triangle ABC is congruent to triangle DEF. Okay? So remember that angle has to be right here. Okay? That angle has to be right there. Trapped between the corresponding sides. So that's the postulate. I suppose I should point out that you might be tempted to think, well, if I prove that angle C is congruent to angle F, then I can use this postulate. The answer is no, because they're not trapped between the corresponding lines. I mean, it's true because EF is congruent to BC, right? But sometimes your book doesn't tell you what's congruent to what. When you go to use this problem, you'll see in example number 2, they're just going to give me 2 side lengths and the angle trapped between the side lengths. And if they're all congruent, then I can prove that the triangles are congruent using this side angle side theorem. So let's go ahead and do example number 2 so you can see this in action. So now for this one, it's going to be a little different. We're going to draw an image and we'll do like a parallelogram maybe this time. So something like that. So for example number 2, we have a parallelogram, and the parallelogram kind of looks like this, and we're going to label that. We'll call this D, E, F, and G. Oops, that's a 6. And G, And then the only thing they tell us is that these two, they don't even tell us it's a parallelogram. We kind of think that it is. Okay, but let's see what they tell us. We have this picture, and this is all the information we have. And we're asked, it says, what other information do you need? What info do we need to prove triangle DE, whoops, DEF is congruent to triangle FGD. Okay? And they tell us to prove it by the side angle side theorem. Okay? They don't tell us it's a parallelogram, although it appears to look like a parallelogram. Yes?
You need the side lengths for FG and DE.
You could do it that way.
Or FG.
I think.
What I would say, you could do it that way, but there's a little bit easier way. Yeah.
Wouldn't we just use EF, DG, and then FD/DF?
Yeah. So the first thing is, here's the clue. We know that FD is congruent to FD, right? Because that's the reflexive property. And it's shared by both triangles. So now I have two sides, okay? And so to kind of make things a little easier for you, we're going to try to let me change this up a little bit. Remember that this is a triangle here. This is DEF, right? And then this is FGD. Okay? So we know that EF, that should be like that. EF is corresponding, now how do I write the corresponding, is it DG or GD?
GD.
GD. So now I have two sides that are congruent, right? I have two sides that are congruent, okay? And I need to find the angle track between the sides. So to highlight this, I'm going to highlight it again. I have this side and this side. So I need to know that that's congruent. And that is also corresponding to this. So I need to know this. So the information that I need is I need to know if angle FDG is congruent to angle DFE. Does that make sense?